we're going to see is, can it be factored? We're going to answer that question. Can it be factored? Okay. Trinomial in standard form, 8x squared plus bx plus c, right? If you can put b squared minus 4ac, if you put b squared minus 4ac in and work it out, and it's a perfect square, then it's factorable, okay? If b squared minus 4ac equals a perfect square. Do you know what a perfect square is? Okay, that's in geometry. What is it? Perfect square. What's a perfect square number?
25.
Yeah, like 25, 16, 121. Those are perfect squares. Okay? So if you can put the problem in to a perfect square, or if you can put those in and get a perfect square, then it's factorable. Okay? So example. 4x squared plus 8x
Sorry, that was bad.
minus 7. Alright. A, B, C. Alright. B squared minus 4 times A times C. Okay. 8 squared, 64. Negative 16 times 7. 142. No, 112. Somebody else.
16, 7.
64 plus 112 is what? 176. Is 176 a perfect square?
No.
No. So this is not factorable. Which could save you some time. Now, yesterday I was nice and I gave you only problems that would factor. Okay? If you did not know this wouldn't factor, here's what you would do. You would sit and say, okay, I need two numbers that when multiplied equals negative 28 and when added equal 8. And then you're going to sit and stare at that for about 2 hours because you can't come up with those numbers, right? It doesn't factor. It's not factorable. So move on. Do something else with it. Okay? That one's not factorable. You're never going to find these two numbers because they don't exist. Let's try this one. Alright, b squared minus 4 times a times c. What does that one equal? Calculate it out. Figure out what does that equal? What's the first stand? What is it? 121. Does 121 have a square root? Yes, it does. So this one is factorable. You could factor that. You could, yes. Right there. You could say, all right, negative 24 and negative 5. Yep. Negative 8, positive 3. So that one would factor. You wouldn't have to sit and wonder. All right, you have it. All right, let's talk about the difference of two squares. Well, we've talked about all these trinomials, and if they have perfect squares, we talked about what a perfect square is, Now let's talk about the difference of two squares. Difference of two squares. Guess how many numbers we're going to have?
Two.
Two. And guess what kind of numbers are going to be? Squares. And what operation will be in the middle? Subtraction, because it's difference of two squares.
Okay, I thought we were finding like the difference. Of
Jacob, that's what she asked you. She's
subtracting.
like, he said different, maybe he'll get this.
It says difference.
Alright, x squared minus 25. See, that's a perfect square. What's the square root of x squared? And that's a perfect square. What's the square root of 25?
5.
And there's a difference between them. See, the difference, I'm subtracting the difference of two squares. Okay? No. When you see the difference of two squares, very easy. What is it? It is. It's x plus 5. It's x minus 5. Okay?
Good deal.
Our b term is 0. What are two numbers that multiply to equal negative 25 and add to be 0? Yeah, 5 and negative 5. But save yourself some time. Recognize that that's the difference of two squares. Is that the difference of two squares? What's the square root on this one? What's the square root on this? So it's going to be 7m minus 4, 7m plus 4. Okay? Save yourself some time. Recognize that it's the difference of two squares. If you see two perfect squares and a subtraction between them, it's going to be two squares. If you forget, you can still do this, but once you get to that point, you're like, oh, I should have realized that was two squares. Okay? Cubes. Can I move this? Okay. Cubes. Alright, so the sum and difference of two cubes. There's nothing that you can do except memorize it. There's not an x. You just have to recognize that those are two cubes, and you have to use the formula. So we'll start with the sum of two cubes. We have a cubed plus b cubed. So you look at something and you recognize, oh, those are both cubes, and I'm adding them up. It will factor down to a plus b times a squared minus ab plus b squared. Get that written down, and I'll show you one thing. 8x cubed plus y cubed. That's the sum of two cubes. What's the cube root of 8? 2. What's the cube root of x cubed? X. And the cube root of y cubed is y. So this is in our a place, and this is our b place. So when we do a plus b, it's going to be 2x plus y. And then we need 2x squared. So what's 2 squared? What's x squared? Yeah, it's x squared. Minus. Then we multiply them together, which would be what? 2xy plus y squared. That's your answer. There's no math that you we can do right now necessarily. Just memorize this formula. Yes, ma'am.
Okay, where did you get the 2x above? Yeah, that one.
That's A. That's the cube root of 8x cubed. What's the cube root of 8?
2.
What's the cube root of x cubed?
X.
X. Right. So that's A. That's going to be in our A place. Y is the cube root of y cubed, so that's going to be our B. Okay? That's the sum of two cubes. You have that one written? Yes? Okay, let's look at the difference of two cubes. What's the difference here? What's different about this one than the last one?
Subtraction.
It's subtraction. That's why it's a difference and not a sum. It factors to A minus B. So again, you've got to find what those cube roots are. Times A squared plus AB plus B squared. Now what's different about this part as opposed to the last problem? Right. Here, this sign is different. So we're on the last one. That's a plus sign, right? And that sign's different. What was that sign on the last one? Subtraction. So those are the two different things. You might want to draw special attention to those two, so you know that. It's different. Alright, what's the cube root of m? Or m cubed, sorry. Yeah, so that's going to be our a. Everywhere we see a, we're actually going to put in an m. What's the cube root of 64? That's the square root. 4 is the cube root. So in our b place, we're going to use 4. So it equals a minus b. What's a minus b? M minus 4. A squared. What's that going to be? M squared. What's a times b? And what's b squared? Yes. This does not factor. Check it and see. B squared minus 4 times a times c. That's going to be 16 minus 64. That's going to be a negative, and it gets square root. So that's his factor that it gets.